Thanks everyone for coming. What we're going to talk about today is what we've done at division of Siemens in terms of implementing CI pipelines. I guess we can just begin. So we can introduce ourselves briefly. I'm Jacob. On the left here, this was a picture from my submission to the I'll Be There swampUP video. So I do juggling, I play music, and I like CI/CD and DevOps stuff. I come from a company called Verifa, and we've been working together with Siemens now for about 2 years on this project. And so basically most of the things you see here are things that I've been involved with or sort of driven.
So hi, this is Ravi, and I'm working as a DevOps engineer with Siemens Healthineers point of care division. So yeah, I'm a CI/CD DevOps enthusiastic and everyone over here. And Jacob called me like I'm a curry master. So that's that's something which I will take.
Yeah, well, I didn't want to just have my hobbies and then Ravi. Come on. So yeah, the Siemens point of care is in Boston. I'm based in Finland, so I'm flying over to Boston quite often. And when we're here, we end up having curry like 5 days a week. And Ravi knows his stuff. So yeah. Cool. Okay, so what we're going to do is we're going to talk a little bit about point of care, Siemens point of care, what they're doing. I'll briefly introduce my company as well, Verifa, and then we're going to go through a few different themes of what we've done in our CI pipeline, going through actually building the pipeline, the testing, OSS compliance, managing results, basically some of the main things that we have done. There's too much to cover in this short slot, so hopefully it should be relevant.
So yeah, Siemens Healthineers. So everyone might already know that Siemens Healthineers is one of the leading companies in the world that manufactures the medical devices, and the point of care is an organization unit within the Siemens Healthineers. And so I'll talk a little bit about point of care, what we do. And point of care is basic. So for the folks who doesn't know what point of care testing is, point of care testing is basically the tests that are done, for the patients when they're at the bedside. So for example, imagine if there are no point of care devices. So what will happen? The patient samples are being, taken by the medical receptionists and also the doctors, and they used to send it to laboratories for results, and that could take about days and even hours, or if the medical laboratories are not within the premises. So and the doctor still has to take care of these patient without knowing the results, because the results are not known to the doctor by that within that period of time. So we have developed these point of care devices wherein you can just take these handheld devices to the patient's bedside and just take the samples, and you can just get the results then and there itself at the site. So that is what point of care manufacturing does. And so we are basically leading manufacturers also in blood gas analyzers and also the urinalysis devices. So we are doing great for over decades, and why do we have to come for the DevOps? That's an interesting question, because when we are doing good business, why do we have to come for DevOps? So with this emerging technology, we have doing great business and everything is going good. Then with this emerging technologies, we have a lot of competition in the picture. So we have to, manufacture the devices that are sophisticated and that should be, handheld, where you can be able to provide the updates to the devices within hours, if not minutes, whenever it is required, because you don't want the devices to fail when you're getting the results. So that's the reason, and due to these reasons, we are now developing a next gen products, so which are Android based products. And so that is where we have all the CI/CD everything come into picture.
Yeah, I guess the interesting point with the Android was that now we wanted, traditionally with point of care, they did product lines, right? So they did a product line start to finish, and then they went to the next product line start to finish, and basically there was no reuse across these product lines. So now they've developed a Android platform, which is basically the handheld device, and the product lines will just extend that. So we have an interesting case there where we want to reuse this code, make sure that everybody's using the latest version. And right now we have one product line that's shipping soon, but I mean, this is going to be used in lots and lots of cases. So yeah. Cool. About Verifa, so we're a relatively young company, and we are specializing in CI/CD pipelines and pretty much everything around CI/CD pipelines. So we help with setting them up, we help with infrastructure, we help with analytics, we help with test automation, we help with OSS compliance, and yeah, a lot of basically everything involved in CI stuff. So I get involved in a lot of different areas, which I love doing. So if anybody wants to find out more, then you can come talk to me after this. Be happy to chat. So about the modernization, besides needing to grow with the emerging markets and everything, this is something that we took from Atlassian. So the source is down here if you want to use it sometime. It's been around for some time, and I brought this in when I joined the project, and I was like, does this look familiar? And I didn't really get a reaction because I think everybody knew that this feels very familiar. This is the cycle of manual delivery. So what we're trying to do is we're trying to take all these painful activities and start to automate them so that we don't end up having this, these slopes. So yeah, that's part of the motivation. So yeah, where did we begin? We're not in a context, it's medical and it's FDA and it's regulated, so we're not in a context where we were like, right, we need to just ship fast. What we wanted to do is we wanted to build a really good quality product, and we're more focused on quality than on speed. And I know there was the talk where they said, well, stability equals speed because it's kind of related, but it was more about building the quality product in-house rather than being able to ship externally quickly and frequently. So we were like, all right, what can we put in our pipeline? And we were like, well, we want to build the software, right? We want to do some static code analysis. And again, big focus on quality here. So we didn't just want to put a static analysis tool in and say tick. We thought, okay, well, we need to comply with coding guidelines. So we started looking at tools that could help with coding guidelines. So in the C++ space, there's things like MISRA. There's security standards like CERT and CWE. We had our own internal coding guidelines. So we're like, okay, let's build these coding guidelines into our pipeline and part of static code analysis. So as well, there are security static analysis tools too. So finding things like array buffer overflows and general defects that might leave your code or your system in a vulnerable state. And there are pretty sophisticated static analysis tools now as well. So I mean, we have a lot of static analysis tools running in our pipeline, and we'll get to this later. We also wanted to do architectural analysis. So we had a pretty good design of the software to begin with, and we wanted to make sure that as we developed our software and as the software evolved, that design wasn't just a Word document or a piece of paper that we had some point in time. We wanted to make sure that the end system actually reflected the design, and also that the design evolved together with the software system. So we put a tool in the pipeline which took an XML definition of what the design presented, and then every time we run the pipeline, then we get kind of a validation of, does our software actually reflect what we wanted to make. We wanted to do unit testing, and with that, mutation testing as well. So mutation testing, for those who aren't aware, it's when you run exactly the same unit test, but you flip the bits. So if you have a plus, make it a minus. If you have an equals, make it not equals. If you have less than, make it a greater than. Run the same unit tests, and what you'd expect to happen is that your unit test would fail, right? If your unit test doesn't fail, well, then how good is your unit test? Like, how good are the conditions that have been placed on the pass-fail criteria? Again, some integration tests, some verification tests, some performance tests. So these are like non-functional requirements, sort of thing where if you run a test once, it works, sure, but what if you run that same test over the period of 2 weeks or a month? Does it still work? Obviously, we wanted to have artifact management and tie that into the pipeline. We wanted to have OSS compliance, both on the legal side from licenses and stuff, and also on the security side. And I mean, that was just the beginning list that we had when we were like, all right, let's build a pipeline. And yeah, that's already a fair few things. And again, it's not just a tool and a tick, but we really invested time in going into each of these areas and defining what it is that defines quality, or what it is that defines security in each of these areas. So we had a challenge. we had all these things that we wanted to do as part of our pipeline, but we don't want to run a pipeline that's going to go on for like 5 hours or something, because I mean, that's not really going to help anyone. We still want, you know, quick feedback. So one of the things that we came up with at Verifa, and this project has been where we've kind of pioneered it and implemented it, was this idea of TX. So TX is basically different time points in the development process. So I can talk you through it here, just briefly. If you've got a development team up here, they will create some feature branch or some branch where they can work on, and we have T0. So this is the earliest possible stage in the development lifecycle where you can run any kind of testing. So this would be, you know, running static code analysis and running unit tests at the developer desktop as an initial kind of quality check. Once they commit their code, we can use, you know, Jenkins and pipelines and things and start running these. So the first branch that they push to would be T1. And here we would define a list of stages that we can run as a quality gate. And if that quality gate isn't passed, then, well, they should fix it. Once it is, they can then merge to a shared integration branch, and we can run something like T2, which is, again, more checks. So it's kind of like a pyramid of going from providing feedback quickly and then working up the levels of quality and security assurance, kind of the further on we get. This was something that we created after working with, well, in the project for about 3 months, and we saw, okay, this is a vision. This is what we should aim for. We are really close. We're really close. There's a few things left to do, but I'm sort of happy that we have come this far. So anyway, this isn't actually the implementation, obviously. So I'm going to talk a little bit about the different bits of this now. So I guess everybody here is doing CI, so I'm pretty sure everybody's been through this fun joy of, okay, we want to build a CI system. We want to get Jenkins. So we were given a Windows machine, and we wanted, you know, proof of concept. So we had our Jenkins master on a Windows machine, which you know, has all the stuff that Jenkins has: the JVM, the workspace, the configs, the build node, everything on one machine, all configured manually. And the machine was limited in resources. And for those of you who know kind of the Jenkins community, then this is Jenkins Tyne is what it's called, and it's a very common pitfall where you just cram everything into a Jenkins master and it just scales to the point where it blows up. And you probably have like 300% more plugins than you actually need, because people just install them and don't uninstall them. So we ran into this, not unexpected. So we were like, all right, we want to do things better. So we have, you know, we're software engineers. We can do great stuff. So we wanted something that's scalable, doesn't just break down, and we have control over changes that are going into it. So the natural result was using containers and configuring Jenkins as code. The timing for this was pretty great, because I've worked with hacking around in Groovy scripts and configuring Jenkins masters in the past. It's not a whole deal of fun. But about a year ago, maybe a bit more now, there was a general release for this Jenkins configuration as code, which is a plugin for Jenkins, which means you can define YAML files to provision a Jenkins master. So we converted our old Jenkins Tyne to a YAML-based configuration as code Jenkins master that we can just spin up, and it's production ready in, well, however long it takes to start a Docker image. So that's great. This is the configuration as code logo, and we're running this on Docker Swarm at the moment. But we recently just got a on-prem Azure instance. So we'll be moving things over to Kubernetes now that we have a Kubernetes engine. We still have Windows agents. They're maintained manually, but again, now that we have Azure, we're going to be looking at Terraform and Packer, and, you know, creating these immutable Windows agents that we can just start up and kill as we like, and everyone will be happy. So that's kind of the infrastructure and the configuration that we set up for Jenkins, and yeah, it made a huge difference.
Yes, it did.
It made a huge difference, and it's working really nicely. And when things go wrong, we can just revert, or we can check the Git history. We have pull requests for making changes, so, you know, everything's pretty well controlled.
Traceable, yeah.
About our pipelines, according to this TX methodology. So again, we had lots and lots of different types of testing we wanted to do, and we wanted to balance the feedback together with the completeness of the testing. So our solution was to define stages in our Jenkins files using Jenkins pipelines, and basically have Boolean parameters for the stages in the Jenkins files. So I know it's very common to have a based on branch or based on tags or whatever. But we didn't want to start adding loads and loads of complexity into every single Jenkins file across every project. Instead, we wanted to have a really simple do this, yes or no, for the different stages in the Jenkins file, and instead put the logic into our C job, which creates the pipeline jobs in Jenkins. So this is one huge benefit of configuring Jenkins as code, is that now your Jenkins master is basically like a pipeline. So you can put all the common logic there, and then your pipelines just inherit that. So we have these do builds, do static code analysis, and do unit test, and there's a couple more. It's a bit more complicated, but you get the idea. And when we create our Jenkins master, we have these parameters configured. So basic workflow, same as in Docker. We have a Docker file with a Jenkins YAML and the C job. We build that, and it basically creates a Jenkins master where we have the environment variables, the Windows nodes that we want to be connected, and then the pipelines. And you can see here, for example, project X dev CI has these params: do build, do static code analysis, true, and then so on and so forth. And those point to our repositories where we have the Jenkins files, and then everything's there. So. Deployed onto Docker Swarm, and I mean, this is not rocket science. We're just following Drive principles. So we try and put all the logic into the Jenkins master and into the C jobs, and so the Jenkins files are kind of as simple and clean as possible. Overcoming another challenge we had, where the Jenkins files were growing, and they were growing, and this really helped. Cool.
So common platform, so managing artifacts. So this is another interesting topic, because as we said, we are going to develop a next-gen product for the Siemens Healthineers point of care, but this common platform is a common instrument platform that is being developed Android based, and the core assets that are from the common instrument platform are being used by the different product teams to develop their products. So we are basically going to develop a common instrument platform. So here the challenge is we have to make sure that these core assets that are developed on the common instrument platform has to be distributed to the different teams. So we need to understand how we need to manage the artifacts, and also make sure that how we label these artifacts, because we need to make sure that what version of core assets are being used by the different product teams. So that's where the challenge is, and that's when we find out that Artifactory from JFrog has helped us in achieving this, and we have a lot of success in doing this right now using the Artifactory. So
yeah, so I guess if you refer to the picture, we have kind of the platform team, which is a couple of core assets, but really this is maybe 30, 40 packages, AAR files for Android, and then the product teams have the app which extend these. And yeah, one of the big questions wasn't how can we just give this to the product teams, but how can we control which versions they're using, and make sure that when we test the platform once, we can reuse those tests again for the different product lines. So I guess.
So yeah. So as you see in the picture, this is the complexity that we have. For example, the core assets are dependent on each other. We have to make sure that all the artifacts are, and the core asset, for example, is also dependent on all these other components, third-party components like Gradle and everything. So we have to make sure that all these are stored in the central location, where we should be able to grab this, and we don't want to have different network locations everywhere in the world, and making sure that everyone is deploying from everywhere. So we have to have a central repository, and that's where we have the Artifactory.
Yeah.
So for example, if you see in the Artifactory, as I was saying, one core asset is dependent on the other core asset. So in that way, the core asset X is basically using the third-party components like Gradle and NPM for its compilation, and we are versioning that, and also labeling that, and we are storing them back in the Artifactory. and then the core asset Y is dependent on the binaries of the core asset X. So it takes the core asset X, the version label of the core asset X, and also the third party like components that are like required, such as Gradle and npm for its compilation. And then once the core asset Y is built, like it's being deployed onto the it's being published to the Artifactory, and then we have this app which uses the both core asset X and Y with its own like third party other components to create the app, and then we are storing that back. So this kind of workflow is possible using Artifactory, and we could be able to integrate this into our Jenkins pipeline. So like everything is automated for us right now, so we don't have to do anything manually.
Yeah. And I guess the manual point is really worth mentioning there, because the method that was going to be used for sharing these platforms was going to be to zip stuff up and share it via file share, which doesn't seem too crazy. I mean, I'm surprised at how often it's done, but I mean, this is a massive improvement, because now we can, well, we don't have to do anything to ship a new version. It's just taken care of by pipelines.
So yeah, so how are we managing the artifacts that are going into the Artifactory? So it's basic pipeline. So in this pipeline, you're saying like just get the sources, latest version sources, for example, for core asset X, and then you're incrementing that version. So and then applying the version. So if you can just yeah. So what we are doing basically is like get the sources, just update the sources, and then like increment the version that is on the Artifactory. So we have to make sure that there are versions that are being defined in the Artifactory for each core asset, and we have to make sure that it's being incremented, so we know like what kind of versioning as being provided to the product teams. And once the build is done, like we are publishing and labeling. So basically we are labeling the artifact for core asset, and then like for example, if you consider this as a core asset X again, like we will automatically trigger the downstream, which uses the same workflow mechanism. Basically it updates the sources, and basically what we are doing is here, like we are also labeling the sources, we are also labeling the Artifactory the artifacts that are generated out of the this build, so that like we have a traceability of like what sources are being used and what artifacts are being used into the are being published into the Artifactory.
And I guess the real interesting thing here is, okay, let's say we build the app at the end and we run it in our pipeline, and some automated tests fail. We want to know exactly which version of the app was used, and maybe the code resides in one of our core assets, so we want to know exactly which version of the core asset that was, and we want to be able to get the specific version of that core asset as well. So we have traceability from the app and the versions all the way down to the exact piece of code that was shipped together with that, which which is useful if you're debugging stuff. Cool. All right, so next topic, the OSS stuff. So we want to trust open source code, but we want to verify it as well, and we want to make sure that when we use it, we have the right licenses. I put the Verifa here because I write verify, and I always end up writing Verifa now by accident, or the other way around. So I'm always like writing typos now. So I almost did it in this presentation and thought I'd just leave it there. What we have done, this is actually something from our marketing material, but it reflects exactly what we've implemented it, so I thought I'd just stick it in. We have OSS Compliance built into our pipelines now. So the basic workflow is that together with the build, and as part of the pipeline, we do the library identification. So we use YSource at the moment, and that gives us a bill of materials. So it tells us the whole tree of dependencies that we're using, the licenses and security vulnerabilities about those as well. And we use an open source tool called Software 360, which is basically a database for storing components or third-party libraries, whatever, about their licenses and such. And it's a place where legal can go, and they can tick, 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 or cross to say whether we can and cannot use different licenses. And we're synchronizing across the latest bill of materials against what's already in the catalog, so that we get this diff as part of every pipeline run. And together with that, we have a license debt indicator, so we can see at any point in time how much debt do we have to pay in terms of getting our project cleared. And then the goal is continuous compliance on the license and security side. In the long run, we'll be adding the more of the continuous delivery stuff where we're generating OSS README with copyrights and such, and a clearing report together with our final artifact binary. So these are the steps we've taken to implement OSS compliance. Should actually be third-party compliance into our pipelines. So we have pretty good visibility now of what we're putting into our software and what state it's in. And the idea now is that if a developer were to pull in, a GPL3 library or something, then we get it flagged immediately. So they don't start developing the code base around this, and then 3 months later, we're like, hey, you suddenly just got to rip this out now, or figure out a way to comply with the license. Yeah. So on to automated testing. I'll quickly cover, our product, which is, we have hospital networks. So again, we're not in the cloud, and these hospital networks are probably closed and don't have internet access, so that poses an interesting challenge. The doctors will hold the Android devices. These Android devices are connected to engines, which is where we put test tubes, blood samples, urine samples, whatever. They communicate via Bluetooth, and when we do the reading on the device, we get the results back to the Android device. And we'll have a database on site as well, where we can have a secure channel to store information on the hospital network. So that's pretty much the setup that will be our customers will be using. So we wanted to replicate this as much as possible in our lab, so that we can test this as closely as possible. So we have an R&D network, which again is pretty much offline, and we put some machines there. We connected Android devices. We have an emulator for the engine, so we run the emulator there. And we have an emulator for the database. So with this, we can pretty much emulate the end environment on the Android side. So we built a few more of these, and these are all on premise. And we're using a tool from Finland called Tau by Profilance, and it's basically a server together with clients here. And this server is, controlling the clients or the nodes. It's, typical server-client architecture. What's really cool about it is that it knows everything about these Android devices. It knows the phone it is, the device, the manufacturer, the version of Android OS, the applications that are installed on there, the versions of the applications, like pretty much everything. So we have one central dashboard that we can go to see our entire testing lab. This makes it nice because when we run our pipelines, we just send a test request to this server, and it figures out based on some parameters like the device pool or the project where to run this, and it will then push it down to an Android device. We'll run some UI tests and test automation stuff, and feedback some results to the Tau server. So we have kind of one entry point for our entire testing lab now. We use this for the integration test that the development team writes. We use it for the verification test that the test team write. And we're also using it for the non-functional requirements. So one of the things we wanted to do is reuse test cases as much as possible. So we're already building out a whole test suite of test cases, and one of the nice features of Tau is that we can just take those test cases and say, hey, put these in a random order and then run them for like 2 weeks. So we don't have to create any more test cases to have our non-functional test running or our stability test running. We can just reuse the tests that we've already written. And actually this has a knock-on effect as well, because this requires you to write like really good quality test cases as well, like idempotent test cases that you can run in any order. So we have pretty much everything solved in terms of test automation with this setup.
Yep. So you have talked about so many tests, so much of testing, and so much of code quality. So where are the results going then?
Yeah, exactly. Yeah, we have a lot of data being produced, like a lot of data. We have all this static analysis, we have all these unit tests, we have all the on-target testing, we have the OSS compliance. So we needed to make that data usable by the development teams. So we use SonarQube for basically a code quality dashboard. We don't really use the SonarQube analyzers as much. We use lots of different static analysis tools, and we've integrated them into SonarQube so that we have like one central repository for code quality information. So that means once we've ran all our static analysis, we have the one like source of truth for quality defects. Then we can just reference that as part of a quality gate, and either tell the dev team that hey, you've introduced new things, or actually your code is of high quality. We've got the pipelines as well, which obviously do all the different types of testing and all the different activities that we have set up. This is a picture of Tau. So these are our test results, and where we can go and get basically any information we want about the automated test that we've ran overnight. One really good thing here is that we get profiling information as well. So if we run our pipeline based on a check-in or overnight, and a test fails, the obvious thing we need to do is go and like reproduce that failure to try and figure out what went wrong. Well, we've captured all the profiling information like CPU usage, RAM usage, battery usage, any crashes on the Android device, all the different services that are running in an Android device. So we can just go to our Tau server interface and get all the information we need to go and debug an issue. So we shouldn't have to go send an email or something to a developer to say something has failed, reproduce this so that we can fix it. Instead, something has failed, here's all the information you need to go and fix it. You don't need to do anything other than actually fix it. But we leave that to the dev team. And what we're working on now, we had a proof of concept a few weeks back, is putting together we have all these different dashboards, but a dashboard on top of the dashboards. So some way of collecting all these results and information into one centralized place. And we're looking at Mosaic now, which is an open source framework for this. To try and bring in all the relevant information and represent this information to different people. We care about this test lab. When these nodes go offline, we want to know. We care about the Jenkins environment. When that goes offline, we want to know. We care about pipelines failing. The dev team, they care about defects, findings, tests failing. The stuff that they're involved with. And managers, they care about seeing the different activities we're involved with. Code quality indicators, OSS compliance indicators, latest snapshot of test results and stuff. So right now we're going to work on defining our kind of high-level dashboards and bringing all this data that we have and make it representable and usable, so that when people ask us what's the status, we can just point them somewhere. Yeah. So
central dashboard.
Yeah. Cool. So
future plans. So what are our future plans? Just do what you're doing now. So don't break anything. Just keep doing. And then it should be continuous. So everything should be continuous as we are talking. So we want a continuous pipelines. We want continuous delivery. We want continuous integration. So yeah, start doing everything we do and make it continuously. So
yeah, in fact, we with medical devices, we have this CIL, the configuration item list, which is basically what we need to ship together with the product. And we're now strategically going through that to tick off, okay, can we do this, can we do this, can we do this, and then put that into the pipeline. So I think where we are today is CI, like a pretty good, mature CI environment. And now we're looking at moving that towards CD, which in regulated environments and such is well, it's possible. So we gotta, that's like the next big leap for us is getting there. We have this notion of DocOps as well. I mean, everything's ops. So DocOps is the generation of objective evidence, of test reports and stuff that we want to ship together with our products, either internally or externally. We have to continue learning and adapting to new technologies, and I guess also helping the other guys within our teams and our company try and adopt to it too. So that's what we refer to as human ops. Is when you really want to do something cool and great, and other people don't agree. Well, we're not all perfect. So
Yep.
So I guess as a summary, we have a pipeline. We have lots of things integrated into that pipeline. We have pretty good feedback cycles. And I mean, we haven't talked so much about Artifactory, but it's pretty much serving everything that we do. And that's, in fact, a theme for us, is that we don't really talk very much about Artifactory because it just works, and it's just there, like, in the background serving its purpose, which is exactly what I'd like technology to do.